You guys can start the presentation and the 5-minute timer will begin.
Okay, so our third member, Lucas, has really bad internet issues right now, so he's unable to present, but hopefully he'll be able to come back during the Q&A round.
If there's technical difficulties, do you guys need to be moved after?
No,
No,
he's
it's
just
fine.
in the woods on a camping trip right
Oh,
now.
okay.
Yeah. Okay, good morning, judges. My name is Shannon Zhang.
And I'm Yichang Lu, and together we bring to you First Focus, an AI software that mitigates disasters.
72. That's the number of hours after disaster that determines whether or not you survive. 72 hours is the amount of time emergency responders have to find you, but they're wasting valuable time guessing where to look. In all natural disasters on the left, studies show that logistics are the real problem, less medical or environmental factors.
When the disaster hits, the bottleneck is often the lack of information. Responders don't know where worse damage is, which roads are blocked, or who is cut off. First Focus is a website model that ranks areas by severity, so responders go to the highest need spot first. We also identify blocked roads, risk roads, and possible helicopter landing zones for easier accessibility after a disaster. Ultimately, our product is a dashboard summary of prioritized areas after a disaster. This way, especially in areas with less documentation, emergency responders know where to go first and how to get there. It works across earthquakes, floods, wildfires, cyclones, and landslides, all from just one pipeline.
We have three models on this website. The first is disaster model, where it will take an input aerial image and output a disaster severity score. We tested both VIT and CNN models, and ultimately chose CNN because it achieves similar results at a lower cost.
After training on 10 epochs with a batch size of 64, we arrived at a near perfect accuracy of 99.96%. Because normal images far outweigh disaster images in number, a model that only predicts normal images for everything would still score really high for a really bad model. Thus, we calculated a weighted accuracy which measures every disaster image and validation test sets to be worth around 10 times as much as a normal image.
The next model is a road access model. Using ResNet50 CNN model, it looks for road conditions, either clear or blocked, and outputs a probability for accessibility of the roads.
After training on 12 epochs with a batch size of 32, we achieved a 100% accuracy score.
The final model is the helicopter landing area model, using ResNet50 CNN model again. It searches patches for open landing areas, such as field and parking lots in the case of blocked roads. It then draws bounding boxes around likely landing locations.
After training on 12 epochs with a batch size of 32, we achieved a 99.79% accuracy.
And here's the overall user flow of the website, which we'll be explaining in the demo video. And here are some images of the website in action. And I'm going to send the link to our website in the chat along with sample images so you can test it on
So
your own.
first we're going to try it out on an earthquake aftermath image here. We're going to drag it into the box where you upload the aerial image. And then pressing this preview sections button will take the same image and split it into 12 respective grids that we rank, all numbered for the user to know which grid is which. Here is where you put the population estimate of each grid. I'm going to put in random numbers. And these grids with people, as you can see, are valued the most because people's lives are the most important. And if you're unsure of the population, you can leave them all as 0, as I'm doing here. And then we're going to calculate. Here, this grid on the right is rank 1, meaning first responders should go there first. Scrolling down on the website, this table will explain the urgency scores and how the ranks were actually chosen for the image. They're due to the image score and the population score. After, another model will identify roads and output a percentage representing the confidence for accessibility due to the blocked roads. Then another model will copy the original aerial image and add bounding boxes for areas for a helicopter to land for rescue. Perfect. And I'm going to show you another example of another image. Pressing the button, and down here, this grid is the most important for rescue as calculated from the model, and this is probably due to the house, that it's the most directly affected by the landslide. And down here are the areas for the helicopter to land due to the blocked road, all clustered around the road.
Right, and that is a demo video. So for our market analysis, our main target markets are regional and national emergency management agencies, humanitarian organizations like the UN, and potentially insurance companies. Our main goal is to keep this tool accessible to all populations that need it. So we plan to sell our product as a partnership with these organizations rather than a paid service.
As for competitors, both NASA's ARIA program and USGS's early disaster assistance are very slow, taking 1 to 2 days. Current solutions focus on building damage, classification, and are limited to only one single disaster type.
To actually gain feedback for our product, we visited our local fire station and talked with the firefighters who stated that our product would be useful in a real setting, especially in rural areas with less incorporated roads.
Lastly, for our future steps, we plan to partner with regional emergency response teams or fire departments, and also plan to factor in historical patterns from disaster disaster into our calculations.
And that is it. Thank you very much.
Thank you. And now, please, the judges for questions and comments.
A nice presentation, really. You've well thought out the problem set and a solution, and you've tested it locally, so all very good steps.
Thank you.
Yeah, I echo what Derek just mentioned. It's a very good presentation, and your solution is quite complete. One technical question is how do you get the population number of each the image if you are in a real world scenario?
Yeah, that's
Yeah.
a really good question. So, first would be like past tenses info. So one thing mentioned in future steps is be able to incorporate like history and historical disaster points from the location. So firstly, we can use like world population, which is like an API that estimates each square. Secondly, we could possibly use like just from the image itself if we actually detect people in that. There are multiple ways that we can incorporate this, but ultimately it's like a future step that we plan to automate this process. But for now, it lies in the hands of the emergency responders itself.
Makes sense. Thanks.
I really like the robust evaluation you guys did. And I just want to follow up is where you guys get the data for the evaluation training data.
Yeah, so these are all currently public data sets. In the future, we do plan to just use satellite images of our local area or local areas who need it specifically to make more specialized models. But for now, these are just generalized like satellite images.
Great.
Is there any more questions for this team?